Welcome to class. Today I'm going to be introducing you to a very interesting concept. Let's begin the journey. We'll be looking at the structure of an atom, basically what an atom looks like and how an atom can be represented, and subsequently we are going to look at what it means and how we can represent it when an atom loses an electron or gains an electron. We begin. An atom looks like this when viewed through a very powerful microscope. What you are seeing here are the electrons, and it has a positive core called the nucleus. Now, inside the nucleus, we have protons and neutrons. Protons and neutrons inside the nucleus. The proton is positively charged. The proton is positively charged. The neutron has a charge of 0, or you can say it has a neutral charge. The charge of the neutron is not positive and is not negative, 0, or you can simply say neutral. And the electrons has a negative charge. The electron is negatively charged. If you look at this atom, you would see that the electrons are moving around the center, which is the nucleus, also called the positive core. The positive core, which is the nucleus, which contains protons and neutrons, is considered positive because the proton in the nucleus is positive, while the neutron in the nucleus is also neutral. That makes the overall charge of the center of an atom, which is the nucleus, to be positive, also called the positive core. The electrons, which moves around the nucleus, the concept that is coming to us right now is just like the planets moving around the sun. The sun is the center of the solar system, just like the nucleus is the center of an atom, while the electrons are moving around the nucleus. The planets moving around the sun. So if you look at this model of an atom is a very basic model which was accepted to a great extent by many scientists. And this model was a model put forward by a man called Rutherford. Yes, this was Rutherford's model of an atom. He discovered this at the instruction, following the instruction he gave to Geiger and Muller, his counterparts, the persons that worked with him. But the most interesting thing here is, be it the structure of an atom, how can we represent this? If you look at this here, every element contains an atom. An atom is the smallest part of an element that can take part in a chemical reaction. Is an atom the smallest part of an element, that can take part in a chemical reaction? That's a modified definition. And for any element, that atom can be represented as X. You would see a superscript A and a subscript of Z to your left, where A is representing the mass number, and where Z is representing the atomic number. Remember, according to a man called Mosley, in order of increasing atomic numbers. The elements you see in the periodic table are arranged in order of increasing atomic numbers. What is atomic number? The atomic number is the number of protons present in one atom of an element. The number of protons present in one atom of an element is the atomic number. Remember that the proton is positively charged. Also note that in addition to the division of an atomic number, A is the mass number. Now, what does A stand for? I have said that already, that A, mass number, Z, atomic number. But there is an expression for A. A is given as the atomic number plus the number of neutrons. Atomic number plus number of neutrons give us A, which is the mass number. Note, at ground state, number of protons is equal to number of electrons. At ground state. And it is also important for you to note that Z is number of protons. So at ground state, we can also say that the mass number is number of electrons plus number of neutrons. Because at ground state, which is the same thing as number of protons plus number of neutrons. Because number of protons is the atomic number. And at ground state, number of protons is the same as number of electrons. What is ground state? Ground state is a state of an atom in which that atom has not lost any electron and has not gained any electron. If an atom is partaking in a chemical reaction, electrons are lost or electrons are gained for a normal chemical reaction. Chemical reactions that involve protons in the nucleus, they are called nuclear reactions. So for a normal chemical reaction, it is the electrons that will be interacting either by electron loss or electron gain. So when an atom loses electron or gains electron, that atom is no longer at ground state. Ground state is a state where that atom is not losing electron or has not gained electron. Ground state of an atom is also called the unexcited state of an atom. It is also called unreacted state of an atom. It is also called uncombined state of an atom. That atom is not combining with any other element. And when an atom is at ground state, the charge, you will not see anything here. The charge is zero. You will not see a positive charge here, you will not see a negative charge here. So, but anytime you see a charge in an atom, just know that that atom is not at ground state. That atom is in its ionic state. So, ionic state of an atom is a state of an atom whereby that atom has lost electron or gained electron. Ion can be positive and ion can be negative. Before we talk about that, let's do some investigation about the very important atom, which is sodium. Looking at the sodium atom, you can see that the atomic number, that is Z, is 11 and the mass number is what? 23. So, you can quickly be asked to find the number of neutrons. The number of neutrons is simple, alright? So, if atomic mass rather, is plus number of neutrons. Atomic mass is 23, atomic number is 11 plus number of neutrons. So to find the number of neutrons, take 11 to the other side, to the 23 minus 11, which is n. So for this sodium atom, the number of neutrons is 12. There are 12 neutrons in this atom. Let's talk about ground state just a little more. This atom is at ground state. Why? Because I'm not seeing any charge here. It's supposed to be a charge here, but there's no charge there. So what's happening? It means that the number of electrons is 11 electrons and the number of protons is 11 protons. How do I know this? I know this because this is my atomic number. Atomic number is 11. That means number of protons is 11. And because it's at ground state, I didn't see a positive charge here, I didn't see a negative charge here. That means that it also has the same number of electrons. Each proton is positively charged. If each proton is positively charged, that means that 11 protons will have 11 positive charges. And 11 electrons will have 11 negative charges. 11 negative charges can also be represented by minus 11. Let's just keep this by the way. What will be the overall charge? The overall charge of sodium atom will be what? Plus 11 minus 11. Let me put it this way. It still means the same thing. Plus 11 plus minus 11, which means plus 11 minus 11. That gives me 0. So the overall charge of this atom is what? Is 0. What is the implication of this? The implication of this is that the charge here is 0. Nothing was written here. That means it's at ground state. The same thing as chlorine. I can be asked to find the number of protons. Of course, in chlorine there is 17, and the number of electrons, of course, in chlorine there is also 17 because it's at ground state. I didn't see any charge here. Let's talk about the overall charge of chlorine. If chlorine has 17 protons and 17 electrons, each proton is positively charged. That means the total charge of the protons is plus 17 and the total charge of the electrons is minus 17. Overall charge of the chlorine atom there is plus 17 plus minus 17, which is plus 17 minus 17. That gives me 0. Most times 0 is not written here. When 0 is not written there, just know that that atom is at ground state. It's not losing any electron, not gaining an electron. The number of electrons is the same as the number of protons. What happens when an atom now gains electron? What happens when an atom now loses electrons? That atom is no longer at ground state. Let us investigate those kinds of atoms. I'm still going to use sodium and chlorine as an example. Let's look at it now. If sodium atom loses an electron, meanwhile, sodium is a metal. Most metals loses electrons. Chlorine is a non-metal. It is going to do what? Gain electron. Metals loses electrons to become electropositive. Metals loses electrons to become electropositive. Or you can say positively charged. Non-metals gains electrons to become electronegative. you can say negatively charged. Moving forward from there, because sodium is in group 1 in the periodic table, it has one valence electron, that's one electron in the outermost shell of its electronic configuration. It is easier for sodium to lose that electron than for sodium to gain 7 electrons. At the end of it all, there must be what is called octet configuration. So it's either 7 sodium loses 1 electron or sodium gains 7 electrons. Why am I saying gain 7? 7 plus the 1 it has in the outermost shell would make it what? 8. So sodium will lose 1 electron because it's group 1 in the periodic table. So when sodium loses 1 electron, the atom of sodium will now be 11 protons and 10 electrons. Watch this. What is the overall charge? Plus 11 plus minus 10. Overall charge will be plus 11 minus 10, which is what? Plus 1. If sodium atom loses electron, the atom is represented as Na plus. This plus, the one is not usually included, alright? Plus Na plus. Because that's the overall charge. When you see a positive charge or negative charge, know that that atom is no longer a ground state. For sodium to react to give in any compound, it has to lose 1 electron. Let's look at chlorine. Chlorine, it is in group 7. That means that 7 electrons in the outermost shell. It's either chlorine loses 7 electrons or it gains 1 electron. Gain 1 to the 7 it has to have 8, octets, 8. But it's more difficult for chlorine to lose 7. That is why chlorine, as a non-metal, will gain just 1 electron. So that means that number of protons will still remain 17 protons, but electrons will no longer be 17. It has gained 1 now, so it will now be 18 electrons. Let's check the overall charge. Plus 17 plus minus 18. That's plus 17 plus minus is minus 18. That gives me minus 1. That means that for chlorine, for a non-metal like chlorine, it will get electrons to become electronegative. That's negatively charged. The charge of chlorine will be Cl minus. So, these two atoms, this representation right now is no longer a ground state. Atomic number is still 11, which is number of protons. The proton is still 11. Mass number is still 23. That's the sum of the atomic number and the number of neutrons. This is still 17 and this is 35.5. Some persons are asking, 35.5, what do we do there? The mass number of chlorine is 35.5. This is the isotopic mass of chlorine. Isotopy will be treated in another video to explain why this mass is 5.5. Why is it not an whole number? Alright? In fact, this one is not an whole number, it's just an approximated value. But why can't people approximate chlorine? That will be explained in one of our videos on isotopy. Now, back to loss and gain of electrons. How can I represent this sodium atom that has lost electron? A sodium atom that has lost electron, before it lost electron, it was Na. Lost electron minus, it has lost electron, minus E minus. The minus is the charge of electron. That will give me what? That will give me Na plus. Permit me to clean this so that you won't be confused about what I'm trying to do. C minus 18, that gives me minus 1. This sodium atom at ground state loses 1 electron, alright, to give Na plus. How about the chlorine? The chlorine at ground state. So before that, the more proper representation of this is that I will take minus e to the other side. So what I'll have is Na plus e minus. This representation is more proper, more appropriate. What about chlorine? The ground state chlorine will gain electron to have Cl minus. This is the ionic representation, alright, of this. This process whereby sodium loses electron, this process is called oxidation. And the process whereby this chlorine is gaining electron, this process is called reduction. So, reactions involving loss of electrons is that process where electrons is lost is oxidation. The process where electrons is gained is reduction. And if I want to combine these two names, I'll call it redox. Redox. That's reduction, oxidation, oxidation, reduction. So, in our next video in chemistry, we're going to be looking at oxidation reduction reactions, or we say redox reactions. In here, we're going to see how we can find the oxidation number of an atom. We're going to see how we can balance a redox reaction. We're going to see how we find our way around so many stuffs on this particular kind of reaction. Stay tuned to my next chemistry video. It's going to be a very interesting journey. Make sure you like, make sure you subscribe, and make sure you share. Make sure you share and click the notification bell to get informed whenever new videos pops up. Make sure you share. Make sure you share.